Refreshing your memory on derivatives. Day one. Okay, so again, with the apostrophe, that means derivative. Not to be confused with this, which means what again? Inverse. Inverse, okay? And realize that derivative is basically another word for slope. When you find a derivative, you're basically finding the slope of a curve at a particular point. Okay? That's what derivative is. This formal definition here that you guys see is the formal definition for finding a derivative. We're only going to do one example of this because I would hate for you guys not to know how to use it on the exam if they ever ask you to show using the formal definition of a derivative. What the derivative is. So please make sure that you do have this down. Does everybody have this down? Yes. Okay. It's also in your reference book, okay? And actually I'm missing a part to it, so please add in the limit as h approaches 0. Basically what that means is that after we simplify everything, we're going to plug in 0. Because we're basically trying to figure out what's happening the closer we get to the curve.
The limit. You'll find out.
The limit is basically, basically as we approach a particular value, like along the curve, like the closer we get to 2, or the closer we get to 4, or the closer we get to 0, what's happening to the y values? That's basically what we're trying to figure out. So that's what that means. So we're going to use this formal definition to do as such, okay? This one is going to go into your notes, okay? This one's going to go into your notes.
Is this formal definition?
This is using the formal definition, okay? So.
It looks so easy.
It's gonna be hard.
No.
Okay, so here's the formal definition. With the limit. Okay?
Do our voices pick up on
Yes, especially since the air's not on. Alright, so what does this mean? What does this first part mean? Okay, so basically we're going to plug in x plus h for every x that we see, just like what we do for regular functions, okay? F of 2 means we will plug in 2 for x. So instead we're just going to plug in an x plus h. So we have 3 times x plus h squared plus 2 times x plus h. You okay? Periodically we check it out. So that's the first part. Now the second part says to subtract f of x, which is just what? The original function. Now realize I'm subtracting the entire function, so you want to make sure you put the second, the function inside of parentheses. Because what I'm going to do with that negative when I simplify? Distribute. You got to distribute. Last thing I'm going to do is I'm going to put all of this over h. Alright? So now we simplify. Okay? First thing we need to do is expand that x plus h squared by foiling. So that's x squared plus 2xh plus h squared. Because remember, x plus h times x plus h is x squared plus xh plus xh. So we just went ahead and combined those like terms. Is everyone okay?
Yep.
Alright. Then over here for this next part we're going to distribute the 2. 2x plus 2h. And then over here, what are we going to do with it?
minus 3x minus 2x.
Okay. And all this is going to be over h. Now what am I going to do with this 3? Distribute. Okay, since I'm a little bit short of space, unlike you guys, I'm not going to put over h yet, because I still have to distribute that 3. I'm just trying to save myself just a little bit of space here. Okay? So I'm distributing the 3.
And now we cancel.
And now we cancel. Things should cancel, okay? Everything that does not have an h in it should cancel out if we did everything correctly. If it doesn't, then we didn't, okay? So, what cancels out?
3x squared.
3x squared and a negative 3x squared and 2x.
All that.
Let's cancel out. So I'm left with 6xh plus 3h squared plus 2h all over h. Now we're just simplifying right here, okay? Now mind you, all this is still with the limit as h approaches 0. All this is still with that. That's all the good stuff.
So now we need to take out the h.
Now we can take away an h because every single term has an h in it, right?
Yep.
So we can take out the h here, one h up here, the h here, and the h at the bottom.
And you plug in 0 for h.
And after that, we are finally fully simplified. The last thing we need to do is actually plug in 0 for h, because that's what the limit is telling us to do. As h approaches 0, which means we're going to plug in 0 for h. And when we do that, what happens to this 3h? It goes away. So 6x,
6x plus 2 is your derivative.
They could have done 5 minutes left.
listen, I understand power rule is a lot shorter, but you're using the formal definition here.
Formal definition makes me want to cry.
Okay. So the formal definition is how you find the derivative of a particular function. Now, this here, AJ, can actually be found a shorter method, which I'm about to show you in a second. Okay? But it's good to know. But I mean, this part wasn't too hard, right? Because the formula is given to you, you just gotta plug in and just simplify. And remember to plug in 0 for h after you do it. Okay. So just look at the first one to start with. The power rule basically says that if you're given a function, then the derivative is found by moving the exponent down and then subtracting 1 from the exponent. Okay? So, write this down first, and then I want to show you how the power rule could have been used for that last experiment. Yeah. So power rule basically says to take your exponent and then move it to the front and then subtract 1 from the exponent. So if I move 2 down to the front, this becomes 2, 3x, and then what's 2 minus 1? 1. And then in here, what's the exponent? So you take this, move it down to the front, and you have 1 times 2x, subtract 1, which is 0. Okay, now, anything, probably, alright, so, anything to the 0 power is 1, so 1 times 2 times 1 is
2.
2. Over here was 2 times 3.
6.
Okay. So, I mean, you can use power rule for everything, but you just need to know how to use it. So, get down the rest of the rules, and then we're going to get to some whiteboard practice. AJ, I'll probably say write down everything. So you got, these are all your rules. You have your power rule, which is the one you can always use. Constant rule, which basically says that if you take the derivative of a constant, like 2, 3, -4, whatever, it's always 0. Okay? Derivative of constant is always 0. Constant multiple, which I was showing AJ in the last one, is if there's a number before your x squared, so say this was a 3, x to the 12, then you would actually multiply the 3 by whatever the derivative was of x to the 12. And then lastly, if you have multiple pieces, like a trinomial or a binomial, then you just take the derivative of each term. Okay? So, whiteboard time. Find the derivative of x to the 12. Find the derivative of x to the 12.
Make sure.
Everyone is correct. Yes, it is 12x to the 11th power. Awesome, awesome, awesome. Clear your whiteboards. Here's the next one. Okay? Here's the next one. Remember, you can write 1 over x to the third as x to the negative 3 using your laws of exponents. And then you can do the power rule here. Bring down the negative 3, subtract 1 from your exponent to give.
-4.
So this would be your derivative, or if I wanted to make the exponent positive, just the x. And that would be your derivative.
Wait, why would you make it +3?
Oops,
Oh, okay, I was
I'm saying.
gonna say.
So can we keep it negative?
So you keep it negative, yeah, unless it told you to only have positive exponents.
I thought that was just proper notation to put it at the bottom.
Yeah, that's proper. Unless it's still me. Here's the next one.
Is it 1/2 over?
It'd be like 1 over 2x to the 1/2.
Yeah,
You just
1 over 2
square
root x.
Yeah.
No, you can't have square.
Oh yeah, you can.
Oh, that's true. Yeah, oh,
So yeah, this. Power rule.
I got x.
I need to wait some notes.
We got this. To make this positive, you bring that x down to the denominator where the 2 already is. This is the same thing as 2 root x.
Okay, so it's
Root x over 2.
That's the answer? What is it?
over 2x.
Because remember, x times x, root x times root x is still
Rational.
x.
So you can leave it 1,
So I would've gotten that wrong.
With that,
no, I mean like 1 over 2x.
honestly, I feel like all 30 of these would be accepted. I'll just have to look at what Mark's scheme would say, depends on the problem. Okay? Clear boards, here's the next one. This. So yes, power rule. Subtract 1. Power rule, what am I going to do with the 2's? Multiply them and subtract 1 here. 15, remember the derivative of a constant is 0. So that is your derivative there. Clear your boards. Here's the next one.
Oh, okay.
1 for the 5. Oh, I didn't hear you.
Oh,
Ooh,
See?
yeah.
I did not hear you.
What?
I did it really awkward.
Okay, like that?
God,
I didn't know you had it.
that you
Okay.
can do that.
Oh, you have
So that is the same thing as writing this. All of those are just
You were right, press the
coefficients. Power rule. All the way down. If I bring 4 and multiply by 1/4, I just get 1. So this is x to the third, because I have to subtract 1 from the exponent. Here, if I bring the 3 into the front, that's 3 times 3/2, which is
9x, or 9 over 2.
9 over 2, x to the
Second.
second, because you still subtract 1 from your exponent.
Yep.
Here, bring down the 2, and it becomes a
Negative
minus 4x. And the last one is,
15 over 2.
because when you take the derivative of your constant, it is 0. I didn't even ask you guys to look up. Okay.
It's okay,
Did you
yeah.
guys get it right?
Yeah.
Is it the same thing? Or do I have to put the fractions?
No, that's right.
No, that's good.
All right.
Put a 7.5
So far, AJ, you feeling all right? Okay, cool.
Ready.
there. Wait, we should do this one.
All right, here we go.
Prepare your body.
Okay.
Of course.
It's not the
Derivative of e to the x is just e to the x. And the derivative of ln of x is 1 over x. Okay, so these are just 2 that you should just know. So whenever you see ln of x, and actually you take the derivative, it's going to be 1 over x. It's also here.
Or the number of
It
words.
is. Yeah. So here, this is basically just 4 times the ln of x, and the derivative of ln of x is just
1 over x.
so this would just be 4 over x.
Yeah.
That's your derivative. Okay? Now they always this simple? No, of course. Here we go. Here's the next.
It's like the last part.
Whiteboard.
Watch, what do you want me to write?
Let's do it.
I can write upside down.
We're all starting.
Two with your
Here's the next
I
one.
can write upside down.
Whoa, my handwriting is beautiful.
Isn't that change?
This.
Like, who did this? Some second grader? Okay, you guys, yes, the ln of e cancels out, so you're just left with 3x to the 4
There you go.
plus the ln of x.
Yeah.
And then, so you just do regular power rule over here, which is 12
Why can't you write?
x to the third. And then what's the derivative of ln of x?
1 over x.
See,
There you go.
Are you left-handed or right-handed?
I'm right-handed, but I told you, I can write like on the board, left hand, but not,
It's just when you get this.
not down, so.
In your classes, when you do the class, I learned to do ambidextrous.
Alright, clear it off. Here's the next one.
Right here.
So yes, 2 stays alone, the derivative of e to the x is e to the x, and the derivative of ln of x is 1 over x. Alright, let's keep moving forward. Here's the next one. So, for this first part, I think we were all good consistently is 5 e to the x, but over here, the ln of e is 1, so that goes away, so you're left with 4x, and then that's what you take the derivative of,
Oh, yeah.
so you get 5 e to the x plus.
Yeah.
Yeah.
So,
Miss Anderson, that almost looks like my left hand. Actually, you know, it's not that bad anymore.
I was saying, you could, like,
do we
the more you
need to learn
practice
how to
it,
write with our left hand, or should we improve our right hand?
What if you lose your right hand?
you should learn.
Then
You get a scholarship for your
I was like, my father had to, because he can't write with his left anymore. Or he can't write with his right, so he had to learn with his left.
Oh, this
Sorry.
is so much confusion in actually.
You ready? Okay.
Here
we go. You got 2 rules with derivatives. You have the product rule, and please take your notes with the right hand. And for your dominant hand, for my left handies. My lefties. They're not left handies.
Something we should use indeed.
They use D, U, E, X, C, E, E, X. Means the same.
I never learned that.
Oh, about work. Miss Anderson,
Slow down.
what's
Say
work?
Austin.
I looking.
The math term work.
I know that one.
Like W-E-R-K or something.
Oh, okay. I'm like,
Say it again.
it's
It's kind of like
it's
this.
something that does with
Can you give
physics.
me one? This green one's like.
Something that does with physics.
Yeah, it has to do with like differentiation.
Green shade.
Oh, no, I
I'm not
never
prejudiced.
dealt with.
Never went that far.
No, I never did.
Never did physics.
So I say my science classes I had to take in college were psychology, so lab, and geology.
I marked
It
it.
was called Roxford Rocks. That was the Roxford Rocks. Got passes? Nope, sure didn't. Okay, so product rule and quotient rule. Those are your 2 rules here.
No, these and these are the same.
Okay? Product rule is basically when you have 2 functions that are being multiplied together and they ask you to find the derivative. Quotient is when you are dividing basically 2 functions, okay? And so, AJ is not as difficult as the rules look, okay? So basically, for product rule, you are just taking, let's see, so right now. Here we go. Product rule. Basically, again, you have 2 functions that are being multiplied to each other. So to find the derivative, you take the first function and you multiply it by the derivative of the second. That's what this means. So there's the first function, derivative of the second, plus the second times the derivative of the first. Okay? And quotient rule is this over here, which basically says the low function, the function at the bottom, times the derivative of the top function, the high, minus the top function, times the derivative of the bottom, all over the bottom squared. Or as I told them last year, low D high minus high D low all over low low.
Bottom. I like the
Pretty
bottom.
good, right there.
I walked the first product and Quotient was through with you. So you take the first, and then you multiply by the derivative of the second. What's the derivative of ln of x? Okay, and then you add it to the second, which is ln of x, times the derivative of the first. Okay, and the derivative of 3x plus 1 is,
3, 4.
careful. You have 1 up here, bring it to the front.
3
What's the derivative of 1?
plus 0.
And so then from there, you pretty much just simplify. This turns into 3 plus 1 over x plus 3 ln of x. And that's it.
Wait, how did you get?
Why did you
thought-
go to the 3?
Right.
Oh, yeah, that's
How
right.
did you get the 3 plus 1 over?
Because 3x times 1 over x,
Oh, okay, so you just take
so
that
just
out.
3. And then 1 times 1 over x is,
We read
Got
like
it.
x plus 1 over. Oh.
yeah. Or you can write as 3x plus 1 over x.
Okay, I did that.
Because basically if I just multiply this by this, I would get 3x plus 1 all over x. And so I just simplified it
I
out.
think you cancel out and it's 3 plus 1 over x.
Okay. Y'all good? Y'all got that? Y'all straight?
Sure.
Okay.
Round 2.
Here's another product rule. I want you guys to, AJ tries on you. So you have the first product rule. You have the first times the derivative of the second, which is
Alright,
2.
I have a question.
Plus the second times the derivative of the first, which would be
4x
cubed.
9x here.
So that's the hard part, using the rules. Oh, not that way. And then now you just gotta simplify. So I want to distribute the 2 over. I'm gonna follow this other side.
That 6x at the beginning is confusing. That 6x is confusing.
So then I'm gonna combine my like terms to get 10x to the 4 plus 14x to the 3rd.
No, that's what I'm saying. It's not squared.
What?
But it's 6x. It's
Okay, the
X to the
second
third,
term
not
of
X to
the,
the
second line of work, your 6x is cubed.
Yes.
Oh.
That's
Okay.
right.
Oh. Gotcha. Okay.
Okay,
And then
why did you get minus 3x squared?
Because I already had that as a square, so it's now minus 9.
Yeah.
There we go. Okay, so 10x to the 4 plus 20x cubed
This is way
minus
easier.
9x squared plus 12. That's your derivative.
Actually, I'm gonna hold my tongue. I'm not gonna say it's way easier than last year until we get to the trig derivatives.
Those are the ones I can't do. Like,
Quotient rule. We're gonna do this one together, okay? Quotient rule says low D high minus high D low all over low low. So low, D high, what's the derivative of the top? 5. Minus high, D low, what's the derivative of the bottom? All over low, low, which is the same thing as saying low squared. What's wrong?
So I did 2.
That's the derivative. After that, it's just simplifying. Don't worry about trying to FOIL out the bottom. because if anything, once you simplify the top, and like it might be able to be factored, you might end up with one of your factors that cancels out with the bottom, so you definitely don't want to like FOIL just to have to factor it in. Combining some like terms, I'll have and if you think about it, there are no two numbers that multiply to give you 25. So this is as far as you can go. And that should be right. Now mind you, all of these are, of course, f prime of x. It's not writing them. Hopefully that's all right.
Is that
YTX.
x squared plus 1 squared?
See, does AJ know that?
Plus 1 to the fifth. Oh, square.
Okay, that's why I'm confused.
Okay? Next one's on you.
Let's find out.
Here we go. We have low, D high, just one.
Yeah.
Minus high,
Yeah.
D low, which is actually just going to be 2e to the x. All over low, low. So we basically have
One
2e
cancels,
to
right?
the x minus 3
Oh, yeah.
minus 2x e to the x minus 4e to the x.
Yeah, I got that one.
That's my answer.
I can keep going.
One of them canceled.
Can't you,
combine the
Oh, I
two?
can
I combine the
you subtract?
Yeah, I did.
Quick
So-
question.
Yes.
Could you just cancel the 2ex minus 3 with one of the 2ex minus 3's on the bottom?
That's what I was
That's what I did.
I combined, but see, this is not a factor of the entire numerator. If this 2e to the x minus 3 would be multiplied to this negative 2x to the x minus 4e to the x, then you could cancel.
Okay.
Because it's not. Yeah. So putting it in some type of order. And there it is. That is your derivative. All I did was I basically just combined these like terms and just changed the order, which you don't have to. You could let it as minus 3, minus 2x, x, and minus 2.
You would have had to combine like this?
Well, yeah, no, I'm just, yeah, you had to, but I was just saying you didn't have to write it in this order.
Oh.
What's next? Let me see what's next.
Can we move on from
Yeah, like about 12.
Let's do this one. What am I gonna have to apply here?
product?
Products, because this is e to the x times ln of x. So the product rule says first,
First times the derivative of the second.
which is
1 over x times, or plus the second
plus the second,
times the derivative of the first.
which is
E to the x.
I thought it, isn't it negative? Oh, product.
your product. Quotient is minus.
Yeah, I'm thinking about.
So we have e to the x over x plus e to the x ln of x.
No.
Wait, don't those cross out though?
Not when it's to because it's ln of x.
If it was Ellen, yes.
Yeah, it was ln e of x.
Yeah.
But now when it's ln x, e to the x. That would be your derivative. Don't want bad habits. Right? How are we on product rule?
Decent.
Pretty good. Easier than last year.
You should mix them all.
Well, we should not mix them up yet.
That way we can know if we do
Alright, don't be thrown off by d of dt or dy over dt or dy over dx or anything like this. This basically means all the same thing. Derivative. Okay, so when you see this type of notation, it just means the derivative of this. Okay? So, it says the derivative of this function can be written as e to the t of t plus k. Find the value of k. Okay? So first thing I want to tell you to do is find the derivative of this function right here. Okay, go ahead and do that now. then you'll be able to know what K is. Product rule says first times the derivative of the second, which is 1, plus the second times the derivative of the first, which is e to the t. So we basically have et plus t et plus 3 et. Did you guys get that?
Yeah.
Okay, now what you should notice, something.
Take out any.
Combine the
You can combine the et and the 3 et to get t et plus 4 et. And since I have to write it as et parentheses t plus k, what do you think I gotta do? Take out an et to get t plus, so k is 4.
A lot of flying bicycles.
There you go. You guys get that?
That was.
Good stuff.
You could get another child.
I used to love that part.
I've never seen it.
You got 5 minutes left in class.
Let's
Yeah.
just save this
Let's
one.
just save it.
Alright, so we'll pick up
I
Jay
love
on
it.
Leave early.
Yeah.